Hello, my dear students. Welcome to IMS GATE Academy. I hope you are doing great. My dear students, we have already started the foundation course, and I hope this foundation course will enable your basics to go through the basic knowledge of geotechnical, or if you are seeing strength of materials also, Pratik sir has been taking from civil engineering, and we also have been to other departments like mechanical, ECE, computer science and all. So the intention of the fundamental course or the foundation course is make your fundamentals strong. If your fundamentals are strong, my dear students, how many of you feel that you are confident? First of all, when you are preparing for GATE exam, your fundamentals should be strong. So the agenda of the foundation course is to make your fundamentals very good. So we have been discussing various topics on geotechnical. Today I am here to discuss you the concept of seepage. My dear students, in soil, this is a big hectic. Very good afternoon Srujana, very good afternoon Jaiprakash sir. Sir, see students, when I talk about seepage, seepage is the most culprit. I can say in design of dams, seepage is the culprit, sir. You should not allow the seepage to happen. So what actually is seepage? So what made you to why you want to study seepage? So see students, if I have taken a prototype like a dam, and here the soil is permeable. Here the soil is permeable, and slowly the water will penetrate into the soil. Now, you know permeability. What is the property of permeability, Srujana? Can you tell me? It is the property of the soil which allows the passage of flow. So if there is more flow of water, then there will be a buoyancy force. There will be definitely a buoyancy force which will try to act in the upward direction. Am I correct or no? So when this buoyancy force is there, there will be an uplift force. It won't make the structure stable. It makes the structure unstable. So that is the reason we should understand seepage. So my dear students, here when I talk about seepage pressure, what do you mean by seepage pressure? What do you mean by seepage pressure? My dear students, what do you mean by seepage pressure? Here see students, seepage pressure is simple. It is the pressure exerted by water. It is the pressure exerted by water on a saturated soil mass. It is the pressure exerted by water. It is the pressure exerted by water on a saturated soil mass. What is the condition of the soil? Saturated. So usually we see seepage in a saturated soil mass where the voids are completely filled with water. So my dear students, here if I talk, what is seepage pressure? It is the pressure exerted by water on a saturated soil mass. Seepage pressure is given by the formula gamma W into I into Z, where I indicates the hydraulic gradient, Z is the depth of the strata, and gamma W is the unit weight of water. What is seepage pressure? It is something like pore water pressure. So pore water pressure is gamma W into H. What is I? Delta H by L. L cancel again into loss of L. Is it clear, Srujana? What is seepage pressure? It is the pressure exerted by the water on a saturated soil mass is nothing but the seepage. Clear, my dear students? Now see students, this was a famous question. Seepage, how does the seepage acts? They can ask you. Seepage acts always in the direction of flow. They can ask you this question, students. Seepage always acts in the direction of flow. Now see students, if the flow is downwards, the seepage pressure will increase. If the flow is upwards, the seepage pressure will decrease because of vertical stress. Okay, based on the flow conditions also, whether the seepage pressure is a positive pressure or a negative pressure, you will get a clear understanding. Okay, I hope you are clear. Now let us understand the concept called quicksand. Sir, if you have observed any English movies or any Hollywood movies, there you will see a sign of, danger like this. It is quicksand. So what is a quicksand, my dear students? What is a quicksand? Most people think that quicksand is a type of sand. Is it a type of sand? Is it a type of sand? Because you are telling it is a quicksand. So are you thinking, is it a type of sand? When you tell it is a type of sand, my dear students, it is absolutely wrong. Okay, it is a condition. What is a quicksand? It is a condition. What is a quicksand, my dear students? It is a condition. What is the condition here is, if upward seepage pressure, I told you already, the seepage pressure will be acting upwards because it is a buoyancy force. If the upward seepage pressure becomes equal to the submerged unit weight, So see students, if you are seeing a dam, there will be uplift force due to seepage. If this force becomes equal to the submerged unit weight, in this case what happens? The effective stress reduces to 0. When the effective stress reduces to 0, there will be a loss of shear strength also. There will be a loss of shear strength. Clear, my dear students? So, when you say the bearing capacity of the soil is said to have good bearing capacity if the shear strength is good. But what happens in this condition is, the effective stress is reduced to 0. In this case, soil loses its shear strength. Once the soil loses shear strength, then it behaves like a liquid also, student. That is the reason, how can you define the strength of a soil is based mainly on the shear strength. So it is almost losing the condition. So whatever the hydraulic gradient, now see student, this is very, very important question. The hydraulic gradient at quicksand condition, is known as anyone, can you tell me? You might have studied. Srujana, can you reply? The hydraulic gradient at quicksand condition is known as critical hydraulic gradient. This is known as what, my dear student? This is known as critical hydraulic gradient. So here please understand, student, the critical hydraulic gradient is nothing but IC. We call IC as critical hydraulic gradient. Now, this is a famous question in all the competitive exams. Critical hydraulic gradient is given by the formula G minus 1 upon 1 plus E. Okay, so are you clear, my dear students? Sai Sujna, is this clear? Whatever the hydraulic gradient at quicksand condition, we call that condition as critical hydraulic condition. Now see students, this is a famous observation. Like quicksand is observed only in cohesionless soils and not in quicksand is not observed in cohesive soils. It is observed in cohesionless soils only, and it is not observed in cohesive soils. Can you tell me what is the reason, sir? Why it is observed only in cohesionless soils? Why it is observed in cohesive soils? Let us understand this, my dear students. See students, shear strength is given by the formula C plus sigma dash tan phi. Agree or not? You might have studied this. What is shear strength? Shear strength is given by S plus sigma dash tan phi. Now see students, if it is a cohesionless soil, what will be C? C will be equal to 0, and anyhow at effective stress is also 0 at quicksand condition. So the shear strength will be equal to 0. But in case of cohesive soil, at quicksand condition, effective stress is 0, but shear strength is not equal to 0 and it is equal to cohesion. Yes or no, Srujana? Can you please respond? Sir, this is a very, very important observation. Quicksand is a condition which is observed in only in cohesionless soils. Why it is observed only in cohesionless soils? Even though the effective stress is 0, cohesion also should be 0 for the shear strength to be 0. Why it is not observed in cohesive soils? The reason is, even though the effective stress is 0, there is some cohesion. With that, there will be some shear strength. So that is the reason the quicksand is observed only in cohesionless soil. So please write a note, students. Quicksand is not a type of sand. It is a condition which is observed in cohesionless soils, because when the effective stress is 0, C will be also 0 in cohesionless. But it is not observed in cohesive soils because even though the effective stress is 0, there is small shear strength due to cohesion. And remember, what is a quicksand condition is, if the upward seepage pressure becomes equal to the submerged unit weight, then the effective stress will be reduced to 0. In this case, soil loses its shear strength, and that condition is known as quicksand condition. Now, Srujana, I will give you a beautiful problem, simple problem. Calculate the critical hydraulic gradient. Calculate the critical hydraulic gradient. When gamma sat is equal to 20 kilonewton per meter cube. I'll give you 30 seconds of time. It is very simple. You have to solve. Calculate the critical hydraulic gradient, and you can assume, for easy calculations, you can assume, my dear students, gamma W is equal to 9.81 kilonewton per meter cube. You can assume gamma W is equal to what? 9.81 kilonewton per meter cube. So what is the critical hydraulic gradient if gamma sat is equal to 20 kilonewton per meter cube? See students, for this I'll tell you. You told me IC is equal to what? G minus 1 upon 1 plus C. But remember students, N is equal to what? E upon 1 plus C. And 1 minus N can also be written as 1 minus of E upon 1 plus C. And this can be written as 1 upon 1 plus C. So this formula can also be written as G minus 1 into 1 minus N, where N is the porosity. Clear? Are you following, students? Now, and another thing, important thing, my dear students, you know gamma sat is equal to what, sir? Gamma W into G plus E upon 1 plus E. What is gamma sat? Gamma sat is equal to gamma W into G plus E upon 1 plus E. Now, if you remember gamma dash is given as gamma sat minus gamma W. So here you can write gamma W into G plus E upon 1 plus E minus of gamma W. And if I take gamma W common here, you can write this as G minus 1 upon 1 plus E. From this expression, you can also write this as gamma dash upon gamma W. So my dear students, please write down this as an important formulas for critical hydraulic gradient. The critical hydraulic gradient formula is given as G minus 1 upon 1 plus C, G minus 1 into 1 minus N, that is equal to gamma dash upon gamma W. Is this clear, my dear students? So here you can write gamma sat is given as how much, sir? Gamma sat is given as 20 kilonewton per meter cube. So IC can also be written as gamma dash upon gamma W. So here you can write gamma dash is what, sir? Gamma sat minus gamma W upon gamma W. So what is the value of gamma sat here? Gamma sat is nothing but 20. So 20 minus 9.81 divided by gamma W is 9.81, or you can assume it as 10. If we assume as 10, suppose students, for suppose if I assume it as 10, critical hydraulic gradient will be equal to 1. Okay, so using this formula, you can easily solve the critical hydraulic gradient. Is this clear, Amma? Is this clear for everyone, my dear students? Okay. Now, next thing what I would like to tell you is, suppose C students, if you consider total head. What is total head, Amma? Anyone? For any soil, sorry, if you consider a flow, what is total head? Total head is nothing but pressure head plus total head is equal to pressure head plus velocity head plus total head is equal to pressure head plus velocity head plus datum head. What is total head? Total head is equal to pressure head plus velocity head plus datum head. Is this clear, Amma? This is what you might have studied. Yes or no, Srujira, is this clear? What is total head? Total head is equal to pressure head plus velocity head plus datum head. Now I have a question for you. What is the question here is, sir, if a water is flowing, Amma, it will have, the water will flow with some velocity. But if you consider in soils, this is one of the objective question in IES also, and in SSC, JEE and all those competitive exams also. In soils, velocity head is neglected because you cannot expect a soil to flow like water. You cannot expect the soil to flow like a water. That is the reason in soils, velocity head is neglected. Clear, my dear students? So they can ask you this question. Because a soil cannot flow like a water, in soils velocity head is neglected. Now, see students, we have some concept like seepage analysis. Okay, we'll talk about a concept called seepage analysis. Now, what do you mean by seepage analysis? I'll tell you. Suppose, see students, if we consider this as a flow net, we consider this as a flow net, okay, and we consider this as a field. This is known as flow channel. This is known as equipotential line. Equipotential line. And this is known as streamline. This is known as what, sir? Streamline. So here, my dear students, when I talk about streamline, what is a streamline, students? Can you tell me what is a streamline? What is a streamline? You might have studied in fluid mechanics also. What is a streamline, sir? It is a line along which, a water particle travels. So what is a streamline? It is a line along which a water particle travels. It is a line along which a water particle travels, is known as a streamline. Now see students, similarly we have equipotential line. So when I talk about what is equipotential line, what do you mean by equipotential line? A line, equi means what, sir? Same. Potential means head. A line joining points of same total head or piezometric head. A line joining points of same head, same total head or same total head, or you can write piezometric head, or you can write piezometric head. Sir, when I talk about total head or piezometric head, I will tell you one thing. See students, in soils, what you have told? Velocity head is neglected, or you can say velocity head is 0. In soils, my dear students, you can remember that velocity head is neglected. Are you following, students? Okay, in soils you are telling velocity head is neglected. When you say that velocity head is neglected, you can write total head is equal to what, sir? You can write total head is equal to pressure head plus, you can write total head is equal to pressure head plus datum head. You can write total head is equal to pressure head plus datum head. So my dear students, when I tell you total head is equal to pressure head plus datum head, you should remember that pressure head plus datum head is nothing but the piezometric head. This is nothing but what, sir? Piezometric head. So that is the reason in soils, total head and piezometric head, both heads are same. Because in soils, velocity head is neglected. That is the reason in soils, total head and piezometric both head are same. I hope you are clear with the concept. Okay. Now see students, there is also a concept called flow channel. What is a flow channel, sir? If you see the diagram here, see students, if you see the diagram here, this portion, whatever this portion is there, no, this portion is known as flow channel. So what you have understand from the diagram is the space between two adjacent flow lines. What, sir? The space between two adjacent flow lines. The space between two adjacent flow lines is nothing but a flow channel. And similarly, my dear students, they can ask you about the field also. Sir, field. So what is a field is, if you see the observation, I am drawing the diagram here. Okay, this can be a field, sir. Okay, this is nothing but a field. So what is a field? The space between two adjacent flow lines and two adjacent equipotential lines. Sir, for your information, streamline and flow line both are same. The other name of streamline. So here the space between two adjacent flow lines, the space between two adjacent flow lines, the space between two adjacent flow lines and two adjacent streamlines, the flow between two adjacent flow lines and two adjacent streamlines is nothing but what, sir? A field. So I hope you are clear with the terms streamline, equipotential line, flow channel and field. So what is a streamline, my dear students? It is a line along which a water particle travels. So what is a equipotential line? It is a line joining points of equal total head or piezometric head. What is a flow channel? The space between adjacent flow lines is nothing but a flow channel. What is a field? The space between two adjacent flow lines and two adjacent streamlines is nothing but the field. And one more important thing, students, what I have observed in the coming GATE exam. See, students, the most successful story of any GATE student who is a single digit ranker. I have been interacting with the GATE 2023 toppers and of IMS GATE Academy, and they have shared me only one thing. Whoever the student is consistent, means taking the preparation diary in a proper planned way, or and they also told that GATE is not a that much difficulty exam if you prepare in a well planned manner. So my dear students, if you want to have an idea about the GATE advantages, like people nowadays, if you see, we have been seeing recession for every 10 to 11 years. But in this, what we have to observe is everyone should look for a stable job. So with the GATE exam, especially for civil, mechanical and electrical, you can have a more stable jobs because lot of PSUs are looking for these jobs. I've been telling in the previous videos also. See, my dear students, if you talk about the public sector, ONGC, NTPC, HPCL, BHL, whatever, these are the basic amenities. If you talk about GAIL, they will work on gas authority. If you talk about NTPC, they talk on power, thermal power. If you talk about ONGC, they talk about oil. So they all work on the basic amenities. If you talk about BARC, it is the government. So indirectly you are responsible for the growth of the nation, especially your social status will also increase. So to make your job stable, and GATE is the only exam where you can prepare while studying itself. Why? Because whatever you have studied in the basic engineering, that will be applied here. If you are preparing well for GATE, means your college level CGPA will be also good, or your percentage will be good. So please keep these things in mind, students, because here we are not to do any kind of marketing or any kind of extraordinary things. We will make the things very simple. Try to understand the basic concept and try to prepare for the GATE exam, and try to improve your college level as well as your increase your weightage of resume. So if you are a Bangalore, visit our center at Jayanagar. We are providing a free demo sessions, Amma. We are providing the free demo sessions on, especially on all the branches. If you are a ECE student, you can go for the demo session. If you are a civil engineering student, you can come for a demo session. And not only at Bangalore, we are the proudly say that we are the only center, we are the only one who are offering the offline GATE coaching at Vijayawada also. At Ben Circle, you can visit our center also. So my dear students, for any success in GATE exam, now we have been starting ISRO series also. Priyanka madam has been providing the engineering mathematics, and Ankur sir has been delivering the lectures on signal systems and all the ISRO previous year questions. So first, try to visit our IMS GATE YouTube channel, IMS GATE Academy YouTube channel. Understand the courses. We have been providing the GATE score booster in the previous for the GATE 23 exam, and we have provided the marathon quick revision formula sheets. Now we are into the fundamental course. So when we do some initiative, the initiative is started just to help the students in a proper and a appropriate way. Okay. Now let us see what are the properties of flow net. What are the properties of flow net? What are the properties of flow net? So see, students, what are the properties of flow net is, if you see the streamlines are something like this. Okay. So the first property is two streamlines never intersect each other. Two streamlines, or you can write two equipotential lines. Two streamlines or two equipotential lines never intersect each other. Two equipotential lines or two streamlines never intersect each other. Never intersect each other. They are almost parallel to each other. Sir, parallel means they maintain same distance. They are almost parallel to each other. This is the first thing. I hope you are clear with when you see the diagram also. So the point here is two streamlines never intersect each other. and they are almost parallel to each other. And another second point I would like to tell you here is, if you see the diagram here, these are the streamlines and this is the equipotential line. So see students, streamlines and equipotential lines are perpendicular to each other. You can write here, streamlines and equipotential lines are streamlines and equipotential lines. Streamlines and equipotential lines are perpendicular to streamlines and equipotential lines are perpendicular to each other. Here you can write two streamlines and equipotential lines are perpendicular to each other. Srijana, are you following? Can you please respond? All clear? Next, if you see, this is the field I told you. This is the field, right? Fields are almost in the shape of square. Fields are almost in the shape of square. Sir, these properties can be an objective question. That is the reason I am listing them. Two streamlines and two equipotential lines never meet each other. Very good, Srijana. Streamlines and equipotential lines are perpendicular to each other. Field, whatever the field which is the between the streamline and the equipotential line, they are in the shape of a square. Now see students, next one what I would like to tell you is drop in head. Drop in head means the loss of head, you can write. The drop in head in each flow channel, the drop in head in each flow channel is almost same. Because they are parallel means their distance is same. Their distance is same means head is also same. Are you getting, Srijana? Here what I would like to tell you is, sir, when you say two streamlines or two equipotential lines, they are parallel to each other means their distance should be same. So if you have a head here at 10 meter, this head is at 12 meter, wherever you find, there will be same, because in that case only the drop in head can be same. If the drop in head is same, then only those two lines are parallel to each other. And the last assumption is the quantity of seepage or the quantity of flow depends on the boundary conditions. What, sir? The quantity of flow depends on what? Depends on the boundary condition. Quantity of flow depends on the boundary conditions. Okay, here see students, here when I talk about quantity of seepage, the quantity of seepage is given by the formula KH into NF by ND. And my dear students, in 2020, there was a GATE question. The quantity of seepage is given by the formula KH into NF by ND. What is K here? K is nothing but the permeability. And capital H is the head causing the flow. Capital H is the head causing flow. And if you talk about NF by ND, NF by ND is known as the shape factor. NF by ND is known as what, sir? Shape factor. Okay, here my dear students, what do you mean by NF? What do you mean by NF, Amma? Number of flow channels. What do you mean by NF? NF is nothing but the number of flow channels. So here my dear students, when I talk about the number of flow channels, see, if I consider this as a streamlines, suppose this is one streamline, this is second streamline, and this is the third streamline. So how many flow channels are there, students? One flow channel and two flow channel. So the number of flow channels will always be equal to n minus 1, where n indicates the number of streamlines. This is very important. Number of flow channels will be always equal to n minus 1. So the quantity of seepage is given by the formula KH into NF by ND, where NF by ND is known as shape factor and NF is known as number of flow channels. And what do you mean by ND? ND is known as potential drop. ND is known as the potential drop. ND is known as what, sir? ND is known as the potential drop. Clear? So here when you solve the problem, what is K you should understand? Permeability. What is H? Head causing the flow. What is NF? Number of flow channels. And what is NF by ND? It is known as the shape factor. That is nothing but the potential drop. Okay. Now see student. Here when I talk about PS, this is known as seepage pressure. This is known as seepage pressure. Seepage pressure is taken as the formula gamma W into H. And here the head is given by capital H, total head loss minus N into delta H. Okay. Now see, here is the capital H is the total head loss, N is the number of drops and delta H is the drop per each head. So for each flow channel you will find a drop in head. So here H can be calculated as H minus N into delta H. Suppose if H is equal to 0, then there is no flow. That is the important symptom you have to observe. So seepage pressure is given by the formula gamma W into H, where H is the H minus N into delta H. And delta H can also be found out using total head loss upon ND. This is another important formula, sir. Total head loss upon ND is nothing but the head loss. What is capital H here? Capital H is nothing but the head loss. What is ND? ND is nothing but the number of potential drops. Number of potential. Sir, these formulas are very, very important when you are solving the problem. Clear, Srijana? Okay. Now let us start. Now let us see the another important thing, that is piping. Have you heard this thing also? What is the piping? Sir, see, what do you mean by piping? Have you heard this time? Anyone? What do you mean by piping? See students, if seepage takes place below hydraulic structures, if seepage takes place below hydraulic structures, if seepage is happening below the, seepage takes place below the, seepage takes place below the hydraulic structures, seepage takes place, suppose if this is a seepage, if seepage is taking place below the hydraulic structures, okay, here there exists a gradient. Now there exists a gradient. Gradient means what, sir? Slope. That is loss of head per unit length. There exists a gradient which is I greater than critical hydraulic gradient. Sir, if I is equal to IC, then the condition is quicksand. If the gradient is more than critical hydraulic gradient, then the condition is piping. In this case, if this happens, what happens is, in this case also, soil loses all its shear strength. In this case also, soil loses all its, this case also soil loses all its shear strength, and the particles tends to, move upward. And the particles means soil particles moves upwards. So this condition is known as piping. So my dear students, what is a piping is, if there is a seepage which is happening below the hydraulic structures, there exists a gradient which is more than the critical hydraulic gradient. In this case, soil loses all its shear strength and the particles tends to move in upward direction. So this is called piping. So immediately Srijana will ask me, sir, you are telling that piping is something due to the flow of water. So how can you avoid this piping? So my dear students, first you make this surface as a impermeable rock. If you make this surface impermeable, what do you mean by impermeable, my dear students? Not allowing the soil to flow. What is impermeable, sir? You are not allowing the water to flow through the soil. So you are just eradicating the water itself to flow, then definitely there will be no seepage. Agree, my dear students? Apart from this, actually what do you mean by gradient? Delta H by L. So the hydraulic gradient will be more if hydraulic gradient will be more, or you can write here, my dear students, it's a common sense here. I is nothing but delta H by L. So hydraulic gradient will be more if the length is less. If the denominator is less, definitely the value will be more. So if you increase the length of the seepage also, the hydraulic gradient or the gradient will be less. So what happens is, if you increase the seepage length, in that case also what happens, my dear students? The hydraulic gradient will reduce. So here, what is your intention? It is simple, amma. Sir, you are telling that when I is greater than IC, piping is happening. So how you can avoid this? You have to make I less than IC. So how can you make lesser? Just increase the seepage length. When the denominator increases, definitely the value will be lesser. Am I clear, my dear students? So in this way, you can reduce the piping. And there was a famous question in GATE exam, amma. What is the factor of safety of piping? What is the factor of safety of piping? The factor of safety of piping is given by the formula IC upon I. Sir, here see, I will ask you one beautiful question, Surajana. Sir, usually the factor of safety will be what, sir? Usually what is the factor of safety? Usually the factor of safety should be 1 for safety purpose. Yes or no? So here, by seeing this formula, what you have observed, Srujana? By seeing this formula, I should be less than IC, for the factor of safety should be greater than 1. Yes or no? When I is less than IC, there is no piping. So this is something where you have to analyze using the mathematics. Simple maths, if you can understand, this is very simple. Okay? Now, I'll quickly revise the summary of effective stress and a seepage. What is the effective stress, sir? See, students, if we consider this as a soil particles, suppose there is a load acting on the soil, the stress taken by the entire soil is known as total stress. The stress taken only by the soil particles is known as the effective stress. The stress taken only by the water is known as pore water pressure, and effective stress, you can write effective stress is total stress minus pore water pressure. 1 second, student. Please be online, student. students. Now see students, when I talk about the effective stress is the total stress minus pore water pressure. And see students, in case of surcharge, the stress will be uniform. Okay. And in case of soil having two layers of different unit weights, the slope changes. Okay. Whenever water table is present, see students, whenever water table is present, gamma sat will be replaced by gamma dash. And in case, see students, in case of stress uniform, in case of surcharge, stress will be uniform. Soil with two layers with different unit weights, slope changes. Water table, gamma sat will be replaced by gamma dash in the calculation of effective stress. And effective stress will be calculated with respect to gamma sat in case of capillarity. Sir, if you can remember this in shortcuts, any problem you can easily solve related to the effective stress. And remember, my dear students, effective stress, the water in the voids exists as structure water, adsorbed water, structure water, or adsorbed water, or they can call it as capillarity water, or it can be written as capillarity water. So what is structural water? What is a structural water? The water which is integral part of the soil is known as structural water. What is adsorbed water? Adsorbed water is nothing but the water which is held in the zone of diffuse double layer is known as adsorbed water. And this adsorbed water will create plasticity to clay, and this has to be avoided. Kerosene, being a non-polar liquid, imparts plasticity to clay. And what is capillarity water? Sir, see students, in case of capillarity, the rise or fall of a liquid is known as capillarity. The rise or fall of a liquid is known as capillarity, and the interconnected voids will act like a capillarity tube through which the water will rise or fall. That is known as capillarity fringe, and this phenomena is known as frost heave or frost boil. And remember, my dear students, when I talk about the effective stress, we also have discussed about what are the stress distribution variations also. Okay. Now coming to seepage, when I talk about the summary of seepage. Sir, what is seepage means? Seepage is nothing but it is the pressure exerted by pore water on a saturated soil mass. Okay. And it always acts in the direction of flow. If the flow is downwards, the effective stress increases. If the flow is upwards, the effective stress decreases. And remember, quicksand hydraulic gradient is given by the formula IC is equal to G minus 1 upon 1 plus E, that is equal to G minus 1 into 1 minus N, and that is equal to gamma dash upon gamma W. And for your information, gamma dash is nothing but gamma sat minus gamma W. So whatever the hydraulic gradient at quicksand condition is known as critical hydraulic gradient. What is critical hydraulic gradient? If the upward seepage pressure becomes equal to the submerged unit weight, the soil loses its shear, the effective stress reduces to 0, and the soil loses its shear strength. In this case, whatever the hydraulic gradient at that condition is critical hydraulic gradient. And critical hydraulic gradient, or we can say quicksand. Quicksand is not a type of sand. It is a condition which is observed in cohesionless soils, because when the effective stress is 0, shear strength will be 0 as cohesion is 0. But it is not observed in cohesive soils, because even though the effective stress will be 0, there will be some shear strength in case of cohesive soils. So here is the formula for critical hydraulic gradient, and very important formula also. And now see students, the quantity of seepage is given by the formula KH into NF upon ND, where NF by ND is known as what, my dear students? Here NF by ND, this ratio is known as the shape factor. NF by ND is known as what, sir? Shape factor. And here, my dear students, NF is known as the flow channels, and here you can write NF is equal to N minus 1. where N indicates the number of streamlines, K is the permeability, and H is the head causing the flow. And remember, my dear students, here capital H can be written as capital H minus N into delta H can be written as small h, and seepage pressure is given by the formula gamma W into H, plus or minus also they will show based on the flow of direction, the whether it is a positive pressure or negative pressure will be given. And you know delta H can be also written as H upon ND. Delta H can also be written as H upon ND, where H is the total head, and ND is the number of potential drop. ND is the number of potential drops. Okay. Now see students, here what is the other thing we have discussed is piping. Okay. What do you mean by piping? Here the main important thing you have to study is the factor of safety. The factor of safety is nothing but IC upon I. And remember, what do you mean by piping is, if seepage takes place below hydraulic structures, there exists a gradient. Where that gradient will be more than the critical hydraulic gradient. In this case, the soil loses all its shear strength and the soil particles move in the upstream direction. That condition is known as the piping. Okay, my dear students, with this we are done with the seepage topic. Okay, if you have any queries related to this topic, you can post me in the comment section. Okay, I hope, see students, again and again I am telling you, we are offering the online courses, offline courses. We are providing 800 plus hours of live gate coaching, and also we are providing 800 hours plus live coaching for civil engineering at Jayanagar, Bangalore, and also at Vijayawada. And my dear students, we have different platforms like doubt portal, where you can post the doubt and that doubt will be solved within 24 hours of time. And we are providing the My Plan sessions where the student can directly interact with the faculties and clear all their doubts. Okay. Apart from this, we are providing the entire gate kit, which is consists of exercise book, theory book, and for every subject we are providing the theory books and also the exercise book. Apart from this, we are providing multiple subject tests, advanced level tests, chapter level tests, subject level tests. Around 130 tests are provided. So if you have any query related to GATE exam or GATE, if you want to really prepare for the GATE, please visit our center at Jayanagar at Bangalore, or if you are from Andhra Pradesh, you can visit Vijayawada center at Ben Circle. Thank you. I hope these sessions will be more and more helpful for you. The only help you can do is just share this session. Thank you.